All right, so when we create a composition, a design, for lack of a better term, that chooses to express aggregation. So understand the importance of those words. What we want the project to say, right, is that it is made up of lots and lots of pieces. Is that clear? That makes sense? Okay. So there are certain ways of bringing things together that are going to highlight that relationship and express that idea. And there are ways of combining things that are not going to do that. So let's start with one condition, okay? If I take these two boxes right here and I place them right up against each other, is it possible that instead of seeing two cubes, that you might see one rectangular object?
Yes.
Especially if you're further away from it.
Yes.
Does that express something made up of many pieces, or does it create an ambiguity? It's ambiguous. You can't tell. If you can see that little line, oh yeah, there's some pieces there. So one of the ways that we can kind of start to adjust for that might be to take the two pieces and shift them one away from the other. Correct? Now it becomes a little bit clearer that there could be two objects, or it could be just one object that's had these two corners cut out. Right? Both of those are viable assumptions. This is absolutely horrible at expressing aggregation. This is a little bit better, but still not so good. All right? So what we did in this previous move was a single axis displacement. An alternate to that is to do a multi-axis displacement, where not only are we shifting it sideways, but we're also lifting it up. Okay? Now, in this particular condition, it becomes a lot clearer, okay, that we have two objects that are separate from each other. Now the line between them isn't an issue. Now it becomes like, oh yeah, there's two cubes that have been butted up against each other. Okay? So of these three conditions, this one is the clearest at expressing aggregation of these three. All right? Let's think about why. So what can you guys see here that you don't see here? Yeah.
Different space.
But let's talk more fundamentally. Over here, is it clear where all the corner points of the objects are? It is? So seriously, I mean, imagine if these things were so precisely built that I butted them together and you couldn't see these lines. Could you know that there's two corner points there? You wouldn't know that, right? Over here, you might see these two, but these two might disappear. Correct? And in this one, you can start to see, because there's a differentiation of all of the planes, right, that all of the corner points are pretty much visible. Even this corner point, right, since you can see this plane and that one lower, you can still see that corner point there. Okay? So the ability to see more of the corner points and edges becomes one of the key facets to understanding an object, or understanding how to express an object, or how to use an object to express aggregation. Okay? Let's talk about some of the definitions that were up on the board. So face-to-face means that two objects or two volumes have two of their faces literally butted to each other. Okay? So there's two faces, let's say, for lack of a better way of expressing it, there's two faces rubbing against each other. Okay? A coplanar face is two surfaces that are sharing the same plane. So both of these surfaces are in the same plane, right? And the greater the number of planes that choose to create coplanar conditions, the greater the ambiguity of whether it's made up of a lot of parts. It becomes harder to tell. That's why this one is easier to tell, because now we've got, we've got a coplanar condition here, but these sides are no longer coplanar like they are here. And here, we pretty much have almost everything not in the same plane. The only condition that we have is that it's a face-to-face connection. Okay? Which leads us to the last and sort of, for lack of a better term, the most expressive of these conditions. Okay? This is a collided condition. It's very closely related to the third condition that we've talked about, where we have changed all of the surface planes, because just like this one doesn't have anything sharing a surface plane, okay, this one doesn't either. But it's creating a more complex condition because now one is overlapping the other. Of all of these conditions, for this project, this is the preferred one. So you are avoiding all of the coplanar surfaces, and you are creating a complex condition where one thing penetrates into the other. Okay? Now let's talk about, for one moment, one other thing. And I'm going to get a different set of cubes for this next operation. This is a third sort of alternative, and I don't unfortunately have it. Actually, what I'm going to do is I'm going to move this over as the best condition and put this one over here as an intermediate condition. Can you guys all see this one clearly? Move these back a little. Okay, so in this particular case, we have one set of coplanar faces. Where is it? Say that again.
The two faces that are coincident.
That is a face-to-face connection. That is different than what I described as a coplanar surface. The ones that are on the same plane. Yes, a face-to-face condition is coplanar, but what I'm talking about is two planes, right, that are side by side sharing the same plane. So where is that condition here? It's on the floor, okay? And this is an acceptable condition to have the bottom part, okay, be a coplanar condition. Okay? Are there questions about why I'm explaining these different conditions to you? No? All right, go ahead and stop that one, Mitchell.